This is what produces tree rings. In the springtime, the trees generally produce much larger xylem vessels because water availability is greater. And then as the summer proceeds and water availability drops off, they start to produce these smaller vessels that you see here. All right, so there's some things we need to know about water in order to understand how plants are actually moving it up a tree trunk. The first thing is that water, for its size especially, has very strong cohesive and adhesive forces. Okay, so in other words, it sticks to itself very strongly, and it can also adhere or stick to other things quite strongly. And what this means is that under the right conditions, particularly because of the cohesion, it allows water to be pulled along, and therefore it can actually act like a rope. Now, what do I mean by that? Let's take a look at this next slide. Water molecules are bound to each other through hydrogen bonding. So you see here we've got a total of 6 different water molecules, and what we're showing with these dotted lines here are the various hydrogen bonds that are being formed between this central water molecule and these other 5 water molecules, or sorry, these other 4 water molecules that are surrounding it. So you can think of each water molecule as like a tiny strand that you would find in a rope, and you can pull on one end of a column of water, and through those hydrogen bonds you'll pull on all the other water molecules. And this might seem a little counterintuitive because you can't reach into a bowl, for example, and just grab the surface of the water and lift up a big rope of water. But when the water is contained inside of the vessels like are found for xylem, it becomes possible to put the water under what we call a strong negative pressure potential and literally have it be pulled up that column. You do this, for example, anytime you suck on a straw. So that water column that comes up the straw is coming up because the hydrogen bonding internally within the different water molecules keep there from being breakage when you suck on that straw and the water comes up in it. Okay. Now, in addition to the fact that water can be pulled, the adhesion allows it to stick to cell walls, and it interacts with a lot of polar molecules very strongly as well, and ionically bonded molecules. And you know about this already. For example, you can take common table salt, and when you put that into water, the polar water molecules align themselves around the different ions from the salt, the sodium and the chlorine, and you end up having the salt dissolve and be bound up within the water molecules themselves.